we're adding another rule, and the rule is called quotient rule. You can, once we do 2.4, you can do quotient rule problems using product rule. That's because I never could remember quotient rule. I was just, for some odd reason, when I was a student, couldn't remember quotient rule. Just couldn't do it. I don't know why. So I ended up having to do everything product rule, and when I did that, I learned how to factor really well, and kind of see how that's going to happen. But if I want to use quotient rule, means I have the quotient of two functions, like 5x plus 1 divided by x squared, f of x divided by g of x. That says if f of x is equal to g of x divided by h of x, it's the quotient of two functions, then this is what its derivative is. It reminds you a lot of product rule, is what it does. Is that f prime is h of x, that's the denominator, times g prime, that's the derivative of the numerator, minus g is the numerator, minus the derivative of the denominator, all over the denominator squared. So, bring the denominator up. Derivative times the derivative of the numerator, minus the numerator times the derivative of the denominator, all over the denominator squared. Now, for me, the way I finally learned it is I was teaching a calculus class at ASU at the time, and I can remember, kind of standing before the class, trying to figure out how do we, it's kind of like if you have a poem that you're supposed to remember, or something that if somebody gives you the first couple words, everything else falls out. And that was me with quotient rule. And I never could remember how it started. I could remember once you tell me how it started. I can get through that like that, right? But I just couldn't remember how it started. So finally what happened was this. I found motions helped me. I know it's weird, but you got to remember I am weird. So, okay. So what do I need to do? I reach down, grab the denominator, bring the denominator up. So once the denominator's up, then it's like product rule. Everybody gets a turn. I differentiate the numerator minus the numerator, which I've already differentiated, times the derivative of the denominator all over the denominator squared. The only difference in that numerator of quotient rule is there's a minus instead of a plus. But you need to know who to start with. So for me, my mind says, bring the denominator up. Once I bring the denominator up, I'm home free. I can go flip through that thing like you wouldn't believe. So that was the way I finally remembered, but I had to be teaching it in order to do that. As a student, I did everything quotient rule, or product rule rather. Some people remember it also using a yodel. And essentially this thing becomes high over low. So this guy's going to become low, d high, that's the derivative of high, the thing that's on the top, minus high, d low, that's the derivative of the guy that's on the bottom, all over low, low. So yodel, low d high minus high d low over low, low. Sometimes things have to be stupid for us to remember them. We remember stupid things, right? Something that sticks in your head, a commercial, right? Some kind of stupid commercial or some kind of song that sticks there. Something that helps you remind you what you need to do. For me, it was the motion of reaching down physically, bringing that denominator up, and then it flowed like crazy. And for you guys, it might be something else. But it's a lot like product rule. And this is why, by the way, it's a lot like product rule. I said that you can take any quotient rule problem. Now, until we get 2.4, which is chain rule, you are not going to be able to do these problems using product rule. It's only after we have chain rule you can do that. I could rewrite this guy as 5x plus 1, bring the denominator up. Now I have taken a quotient rule problem and made it a product rule. The derivative of the first is 5 times the second, which is x to the minus 2. And then you just say plus. Well, if I'm going to differentiate x to the minus 2, what am I going to get in the middle? It's going to be minus 2x to the minus 3. That's where that minus comes from in quotient rule. But I could do this problem using product rule. So any quotient rule problem can be done using product rule if you have all the rules. And which is what I ended up doing because I couldn't remember quotient rule. Quotient rule basically makes the simplification easier. I mean, I had some god-awful factoring problems to do because I couldn't remember quotient rule. Is what happens when you have to simplify. Right now we're not simplifying. So here we go. Bring the denominator up. So y prime, bring the denominator up, times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So now I can complete the rule. I only take it down to the first step. I just complete the differentiation. It's 5x plus 4. What's the derivative of 2x minus 3? 2. Minus 2x minus 3. What's the derivative of 5x plus 4? 5. All over 5x plus 4 squared. This is where, well, it should be prime. This is where you would leave it. Right now. Chapter 3, we're going to do a lot of simplifying. Now this guy, I need to recognize the variable as t, so that y prime is, bring the denominator up, times the derivative, the variable is t, of the numerator, minus the numerator times the derivative, again the variable is t, of the denominator, all over the denominator squared. Now I've got the rule written out. So 1 minus t squared squared. So it's 1 minus t squared. What's the derivative of t squared plus 1? 2t. Minus t squared plus 1. And what's the derivative of 1 minus t squared? Negative 2t. And that's where you'll leave it. Now what you'll notice, however, is that there's a greatest common factor of 2t. So if I had to simplify it, I'd first factor out the greatest common factor of 2t. But we're not going to simplify.